Hello everyone. So today we will start with our ML journey, and the first topic is regression. There are almost there are all there are typically two types of regression problem, two types of ML problems which we work on. First is regression, and second is classification. So first we will start with regression. What is regression? In regression, you will be given one independent variable and more than one independent variable you can but be given, but I am just simplifying this. So basically in regression problem you will be given an independent variable and you will predict the dependent variable on it. Say there is there is a area of area of your house, and you'll have to predict the price of that house. So it is directly dependent, right? The one thing, area is independent variable and the price is dependent variable. So when we predict those things, then that is called regression. Okay, so what is the basic concept we follow in regression? The most, the basic one is how we used to solve the problems for our straight line. If you remember that what is the equation of straight line? That is y is equals to mx plus c. But how, you know, how is regression related to straight lines and the equation which I just wrote here? You would be, thinking. So let me first tell you that say these are some points. Say these are some points. Okay, let me just draw some good points. These are not, good points for regression type of problems, because I'll tell you first. Say these are some points. Okay, this is your area in x-axis and this is your price. Okay, and you can assume whatever x and y here. Okay, so these are some points. So uh, at this area, this is the price. Okay, at this area, this is the price. You are given some points. Now you have to decide for this point some random, you are given area and you have to decide that what would be the price of this point. Okay, how will you do it? You will think that let's draw a line from here to here, and it should capture the price near to this. Okay, and this is the exact foundation that we use in linear regression. I told you the meaning of regression. What is linear? Linear means anything which is in straight line. So this is a straight line. So linear regression, from here linear regression comes. Now this m is called your coefficient, x plus c, and this is called your intercept. And in machine learning we are basically calculating or finding out the value of this two parameters only. In linear regression, coefficient and intercept, if we find the values of coefficient and intercept, we can predict the price for any given x. Okay, you give me any given x and I can predict that price. So this, and there could be multiple x's too, right? m1 x plus m2 x plus m3 x plus c, right? So there could be multiple factors which affect this, which affect this y. Okay, so this is how we write multiple linear regression. Okay, and now let me show you one uh, real ML uh, working of this concept. Okay, uh, here's see first, what is the what are the given things you want to calculate the monthly bill, your electricity monthly bill based on the number of AC units you have in your home, the current temperature outside, the number of people in your family, or the number of rooms you have in a particular house, and the square foot area of the house. So these are all our features, and this is our target. We have to find out the value of this target based on these features. So first we imported all these. We have a CSV file. Okay, I made all these numbers using Claude, and then we will check the size of this uh, file, and that is 50 rows and 6 columns. See, 1 2 3 4 5 and 6. But now, since we have to train the model, we have to split the feature and targets. And you could also do one thing which we will learn later also, that you could check for null. So df dot is null dot sum. So we have zero null values. If we had null values, we would have to treat them. And if we have any outliers also, we will have to treat them. But these concepts are, kept for little later sessions. So we will see that df.info, it gives you all kinds of informations like what is the data type and how many null count are there. And df.describe is also one thing. Okay. Now we will see the scatter plot, that how are these points. There's like how I showed you in the presentation, that how are these points spaced out in the x and y plane. So the how is area in square feet, you can give all those label names like ELT dot x label area, and PLT dot Y label. Y label is monthly bill. Bill, when you run it, you see this area and monthly bill. So if your area is, as you can see you can see clearly that as your area increases, your monthly bill also increases, right? We can get this from this figure. Now again, number of AC units, how this maps to the monthly bill. So as your AC units increases, see, when we have a one AC unit, our overall monthly bill resides in this range. When the AC units go up, like in two, the monthly bill resides in this space. And similarly for this, you can see that as the number of AC units increase, your monthly bill increases. So these are the two things which I got, from this table. Else, all those columns which we saw were not very meaningful, were not contributing too much in the uh, too much in the prediction of that y value. And then we divide this x in features and y that we have to predict, and we do train test in split, so that not all the training or not all the data is gone to train your models, and when you test that model on that data only, it will obviously perform good. So you keep some part of the data aside, so that you can actually genuinely see how the model performs on the unseen data. Therefore, we kept a size of 20% for test size. Means 20% of the whole data will be kept aside, and it will not be used to train the model. This will only be used to test the model. Okay. We did that, and then we imported the linear regression model from this sklearn.linear model, and we defined that model instance, and then we called the fit function on x train and y train, and our model got trained. Then we predicted using model.predict x test, and then we calculated the score. Score is basically the R2 score. You can say it R2 score gives you how well the model performs. We will look into the matrices of how do we classify, means how do we evaluate machine learning models later. But R2 score, for just the to give little context about R2 score, it gives you it tells you how good your model is performing. So our model is almost very performing very good, not very good, but not very bad also. So it is giving us almost 91% accuracy. Accuracy actually is a bad word for regression type of problems, because accuracy is used for classification type of problem. So 91% is the R2 score for this. And if we want to see the intercept, then we'll have to do this, the C value, which I told you y is equals to mx plus c. So the c value is this intercept. And if you want all the coefficient value, then you can do model dot coefficients, and you will get all the coefficients for this model: 1, 2, 3, 4, 5 coefficients. And if you want to say, actually genuinely test and see it yourself that is it actually working or not, you could pass some values like 1600 square foot is the area of your home. There are three a number of rooms. We have four people, and the average temperature in Celsius is 32 degrees Celsius, and the number of AC units is 2. And if we predict that, we get an monthly average bill of 509 5,709 rupees almost. So this is how you train a basic linear regression model. And this is it for today. And I will see you next day. Thank you very much.